Okay.
All right.
Hi.
And then you're
One more time.
you're listening to
Keyboard and Quill.
From StarTree, creators of the Real-Time Analytics Summit.
And
podcast.
I'm Tim Berglund.
I'm Rachel Pedreschi.
This is Keyboard and Quill.
In the last episode, we talked about the origins of analytics, starting with the Belgian astronomer who invented the body mass index.
In this episode, we're picking up with analytics on digital computers, mainframes, in the middle of the 20th century. Initially, mainframes used the same punch card technology we were talking about with all those tabulators in the last episode, but they quickly developed things like magnetic tape drives, which were a lot faster and stored more data in a smaller package, then hard disk drives, which were even better. Things were kind of moving along in the technology behind analytics.
But disk wasn't cheap. In 2024, your phone might have a terabyte of data available to it, but in 1960, that same terabyte would cost you $3.6 billion. Yes, that's billion with a B.
And there wasn't like a 1 terabyte drive anywhere. That wasn't a thing. You would have had
No.
small numbers of megabytes, but that was the cost of the storage.
To put that in perspective, in 2022, it was $14 for a terabyte.
Yeah, that's 250 million times cheaper it's become since 1960. And people are figuring out new things to do with all this data.
So we talked about this with the rise of the IBM 1401 mainframe, and then with mini computers like the PDP-11. But companies began to get into the game. They began to collect data. Bill Inman, one of the founding fathers of modern analytics, tells us about the start of this process.
In the 1955 timeframe, corporations did not have computers. There simply wasn't a computer there. And then for a variety of reasons, in the 1960s, applications started to appear. And corporations saw great worth in the value of computation. They didn't see all of the value, but they saw some of the value. The applications were simply scattered. They did human resources, they did inventory analysis, they did all kinds of things. And the corporations started to hire these technicians to run and master the applications. Well, that was all well and good, but at that time, as the applications were running, what happened was they started to throw off data. And the problem was this data that was being thrown off never was intended to be integrated or used with any other data. And this is what's called the legacy data environment.
And that legacy data environment got pretty interesting. Bill quickly ran into a fundamental problem, which was this. One is those databases he was talking about, those were used by applications to keep track of things in the world that change, like your account information or an order that you place or the status of a shipment.
Inventory
like
is another good example.
Inventory is a great example of a thing that changes. And we'll use this term again, we call that the transactional database. It's a little bit anachronistic at this point to say transactional database where we are in the mid-50s, but that's that database. And he's got this thing where he's now wanting to also ask questions about the data. And there was a conflict there between those two different kinds of access.
We call them transactional databases because they were keeping track of transactions. A sale at a grocery store, the flight status of an airline, your tax records. These are all transactions that happen during the course of everyday business. And companies needed to keep track of all of this in order to effectively do business.
Bill had this idea, which was apparently crazy at the time, of creating a second database, copying all the transactional data into it. Let's listen to his telling of how this went down.
All of a sudden, corporations had this massive amount, ever-growing amount of legacy data. And it was a mess. There's no other way to describe it but a big mess. And one day, somebody said, gee, maybe we could start to do other kinds of analysis on our data. And that's when they tried to use the legacy environment to do analytics from. And that, too, was a mess. There were so many problems, I'm not going to enumerate them, but trying to do analytics on a mess was not a good thing to do. It's into that arena that the world, myself, noticed that we needed to have integration and organization. And that's where data warehouse came from. That data warehouse was simply nothing more than the integration and bringing together of all of these sources of data. And now, was this an easy task? No, it's still ongoing today to some extent. And suddenly the corporation found with a solid foundation of data that they could start to actually do analytical processing. And this opened up a whole new world for people in the world of analysis. And data warehouses started to grow. They had their own characteristics, but they had this environment, data warehousing growing, where they could do analytics from.
It was incredibly important, not just for the stability of the databases themselves, but also for the viability of the business to make sure that you kept as few copies of the data around as possible. So this idea that Bill had was revolutionary because nobody at that point thought, well, the cost of disks are coming down, maybe we should duplicate our data someplace else.
Right. And still, with the costs that you had, $3.6 billion per terabyte, there's just a lot that you're never going to store. And what really struck me in listening to Bill's telling is that not everybody got it right away. IBM, before this idea of a data warehouse even took root, was having to convince companies that the data they were generating and collecting was valuable for any purpose. You know the term business intelligence that we use, Rachel?
I do.
Yeah. What does that mean today? How would you define that?
So business intelligence today is a set of tools and technologies that companies can deploy in order to give non-engineers, non-developers, business users, analysts access to the company data in a way that allows them to ask questions effectively.
And if you'd asked me when that term appeared on the scene, I probably would have told you.
I would say like 1993.
Sure, I might have been crazy and said 88.
Yeah, somewhere around
try
there.
to be all edgy.
Side ponytails.
Yeah, and exuberant hair. Well, apparently it dates to 1958.
Wow.
From a paper called A Business Intelligence System, published by a guy named Hans-Peter Loon in the IBM Journal of Research and Development. Here's Chris Wiggins on that.
It's one of the reasons IBM had to create the term of business intelligence in 1958, was to convince private companies to do something with these massive machines that they had built for the intelligence community, to convince companies that they really should take all their documents and turn them into zeros and ones instead of punch cards. Paper by Loon from 1958, proposing a field of business intelligence, trying to say, look, all of you are deluged with data and documents. Why don't you turn all your punch cards into digital files using IBM's technologies in the enterprise?
Okay, that's why the word intelligence is in the phrase business intelligence.
I hadn't thought about that particular overlap. You'll see that often there was a sort of laziness in the way that they took terms from a military application and turned it into a business application.
So I think to take this back to where from our last episode, we had the Enigma machines and the other pieces of technology that were used during World War II, and they were just, at this point, kind of sitting around. And so IBM's like, hey, we got some good ideas to do with this.
Yeah, this is during the Cold War, so there still is this large intelligence apparatus now pointed from the American perspective at the Soviet Union, gathering all this signal intelligence, these IBM people selling stuff to the government and making it dual use, I suppose in a way that has worked out well. But back to at least more commercial things, I asked Bill Inman to dig into the details of when he created the first data warehouse a little bit more. Rachel called him one of the founding fathers of analytics. He's the guy who created this thing. And the data warehouse has been a huge part of the analytics story in the 20th and 21st centuries. So, Bill, where did you first come up with this idea?
I happened to be working at Standard Oil of California in San Francisco. It was my third company I'd worked for. I was working on transaction-based systems where high performance was the god we worshipped.
So a transactional system refers to a database that's used to keep track of changing things in the world, like orders, customers, shipments, inventory, all those things whose properties can change as a company transacts business with its customers. This is where all the data lived, and it wasn't working to use that same database to answer questions like, what was the best-selling product in each zip code?
Yes. Now, back to Bill.
I don't know what possessed me to do this, but I came along with what at that time was a radical notion. I said, the data we're creating in transaction systems ought to be able to be used for purposes other than transaction systems. And you wouldn't believe, and I'm not exaggerating, you wouldn't believe I was a writer for Computer World, and I wrote that in Computer World. And I got things, this man is an anarchist. Bill Inman should never be allowed to talk in public again. This man is setting our industry back 25 years. And to me, it's a very intuitive, simple idea, but boy, the IBMers and the people that were doing transaction-based systems said there is nothing but high performance and transaction-based systems, and that's all there is. And they were very threatened by it. It was like, I'm not going to use a religious reference, but it was like going into a Catholic church and saying bad words. It was awful.
I think it's fair to say right now that my entire career has been built from what Bill has been talking about forward.
Yeah, it's huge. And you've worked in analytics for a lot more of your career than I have.
All of it.
Right. But Bill Inman and a contemporary of his, Ralph Kimball, they were really the people who built modern analytics as you and I have received it during our careers.
100%. They're both founders of various companies, various technologies, have their names all over this space.
Yes. And for Rachel and me, database is a technical term that carries with it potentially a whole lot of specialized technical complexity that isn't really important to our discussion here. But I think that term is also very understandable just from a popular standpoint. And we all know databases are completely central to the electronically mediated lives that we live.
There are very few minutes in a day with a smartphone in our hand that we don't touch a database at some point.
I asked Bill about the first few data warehouses he built. And again, these were some of the first instances of this technology, now a multi-billion-dollar industry that were built anywhere. Let's listen in.
I know the first 3 data warehouses that were built because I built them. One was at Aetna Life and Casualty in Connecticut. One was in Shell, Canada, in Edmonton, Canada. And one was in Orange County, Pactel Cellular. And I say this affectionately. We got the lunatic fringe. We got people that were willing to take a chance that something else might work. Now, I'll tell you the story about the advent of data warehouse. Pactel Cellular at that time was in a war for market share, for getting new customers to sign up for cellular telephone because cellular telephone was new. And for whatever reason, Pactel Cellular said, let's try this thing called a data warehouse. And then all of a sudden, all of the other cellular companies said, hey, Pactel's got this data warehouse. And management went down to IT. It wasn't IT that went to management. Management went to IT and said, go build a data warehouse. And this is what they've been fighting all these years. And after the success we had in the cellular telephone business, the next big boost we had was from Sam Walton. Sam Walton wrote a book on Walmart in which he mentioned the ability of a data warehouse to help control inventory in the Walmart system. And so between the success in the cellular industry and Sam Walton, suddenly everybody under the sun wanted to build a data warehouse.
It's such a fun story to hear.
I'd like to point out here that companies that have been early to adopt data warehouse and data analytics as part of their corporate strategies are the ones that usually end up winning down the line. We've seen a lot of these examples over time. Bill talks about Walmart here with Sam Walton, but you could also apply the same concept to modern companies like Netflix and Facebook.
Yeah, the lunatic fringe he refers to are the people who are willing to take early bets. And when they pay off big.
After a short break, we'll pick back up at the start of Tim and I's careers when data warehouses were really getting rolling.
I'm Tim Berglund.
I'm Rachel Pedreschi.
This is Keyboard and Quill. We're going to keep going now with more on data warehouses.
Yeah, I have to get a little personal here because in 1997, I graduated from university and I started working in the Silicon Valley. My first job was with a company called Red Brick, and Red Brick was a database that was built specifically for data warehousing. It was a completely new idea at the time. So at this point in the late 90s, the data warehouse market had become an accepted, standard, and for a lot of people, eventually $1 billion business. Even though doing analytics with a data warehouse was a new technology at this point that could be difficult to deploy, and trust me, I was there, every company knew they needed it.
But it wasn't always that way. Let's listen to Bill again, talking about the early days.
In the beginning, IBM fought tooth and nail against data warehouse. Microsoft was no support. Oracle was no support. SAP was no support. I even had one of the executives from one of those companies say, please don't ever mention the name of our company and data warehouse in the same sentence. And I'm telling you the truth. That was the vehemence that the vendors fought tooth and nail data warehouse. And all I had was a story and a truth. Now, I did have converts. In fact, the people that were the biggest allies that I had were marketing and sales. Not IT, but marketing and sales. If it hadn't have been for marketing, we wouldn't have had data warehouse. But the people in marketing, they got it. And they say, give me one of those. But the people in IT were conditioned by the vendor to hate data warehouse. God bless marketing and sales.
Really? Marketing and sales?
Marketing and sales. God bless marketing and sales.
You heard it here first. There were other things happening at the same time. And remember in our episode on the evolution of computing, we talked about what started to push the mainframe out of the picture, at least for new designs.
It was the PC, right?
It was the PC. Now, your laptop these days, your desktop, if you still use one, is basically architecturally a PC. Even if it's a Mac, don't let that confuse you. That really has been a successful technology.
And PCs pushing mainframes out led to this new way of building information systems called client-server architecture. We went through the timeline in our last episode. So now Bill Inman was around when people were touting client-server as a solution to all possible problems, which it wasn't, but he saw the good in it.
I don't know who, but somebody else said it. Now let me tell you about the time client server came along. There has been a sea change in our industry that has happened so gradually that people haven't even noticed it. It's like the tide coming in. The tide comes in one wave at a time. And that sea change is in the very early days up to client server, people were after the technology. But the sea change today is we're not so much after technology as we are after architecture. And there is a world of difference between architecture and technology. Now, we still, don't get me wrong, we still need technology. Technology is still a very active and important player, but we've got so many things going on in the corporation that we need an overarching architecture to make things happen. And that sea change is occurring right now.
This sea change just made his data warehouse idea that much more important. Now a company's data wasn't in one big giant transactional database, it was in lots of little ones. So that data warehouse became a place to bring it all together to learn what was going on in the business.
The first data warehouse that I built actually took data from 32 different systems and combined it into a single data warehouse for marketing to use.
And you were a new grad then, relatively new grad?
This was 2001.
Okay, so you're a few years on the job.
Yeah, a few years on the job, right? And I had been hired by a ski resort to get an idea of how to market to various people to come to the ski resort. And we needed lodging information. We needed skier information. We needed food and beverage information. But yeah, there was 32 different data sources that we had to combine.
The output of all that, these reports, I assume they got printed out on a laser printer or something. Who got that output?
That was the marketing team.
Okay.
So the marketing team was my customer, and they used to use a reporting solution to access the data that I had put into this data warehouse to do all sorts of analytics and analysis on what was going on, so they knew who to send the postcard to.
Exactly. And here's a key point to keep in mind here. We're going to return to this in our final episode in this series. The data that Rachel was talking about in her first data warehouse, in any of these, the output, the reports, they're being prepared for decision makers inside the business, managers of the business, to know what's going on, make decisions about what the business should do. These are usually higher up people in the company, maybe in the marketing team. They're some folks who are running the mailing campaign, whatever, but they're inside the business. It doesn't make any sense at this point in history to start including your customers as decision makers.
No, this was all internal.
Yes, and that is going to change, but not yet.
All right, so how did this affect people at this time? Internally, companies were using this data, and it was fairly popular and well-known.
Yeah, and if you were one of those people, that was affecting your life because you worked there, but then you already know.
But actually, the way that this showed up for somebody outside of work was, strangely enough, first at the grocery store. I don't know, Tim, do you remember the first loyalty program that you signed up for at your local Save Mart?
The local food product store.
Yeah.
I don't remember the year, oddly, but I definitely remember that as a new thing, probably sometime in the 90s.
Yeah, about then. And I remember thinking to myself, well, this is kind of strange because they're just giving me a discount to buy stuff that I'm going to buy already. Or why would they give me a coupon on cat food when I just bought cat food? Wouldn't that not be what they'd want to give me a coupon on?
Right.
But what's actually what you're seeing here is the advent of grocery stores being able to ask questions of their data. And what was really important for them to do is then track the person who made the purchases. So then they could extrapolate, Tim was living in Colorado at the time, and he maybe would buy, I don't know, what two things would you buy together?
I would buy eggs and kale.
Okay, you're not a very exciting person, but maybe you were making a quiche. And so the grocery store would be able to say, hey, we know that Tim is a really health conscious type of guy. Maybe we'll send him a coupon for whole wheat bread, for example.
There you go.
The other ways that this showed up is if you would go to a retailer that would ask you for your zip code when you checked out, and they would say, oh, this is for demographic purposes. But actually what they were doing was they were getting implied consent to make sure that they could then attach your demographic information to your credit card so they could do more analysis. Who are the big spenders? Who are the people who own homes? I remember one of the categories was kids in cul-de-sacs, for example.
Oh. So kids in cul-de-sacs are going to be correlated with some propensity to buy some product.
Probably diapers and beer.
There you go. The kinds of analysis, and it's worth stepping back to part one of this episode. We had this tension between Fisher. Remember, he was the guy with the kind of scientific rigor and the randomized controlled trials. And he's like, anything you do with data, there has to be a null hypothesis. You're randomizing everything except the variable that you're studying. And Tukey, who said, we've got lots of data. We got computers. We could just kind of explore things. It's not like there's some fundamental model underlying this that we're trying to test. Sometimes you just want to look at things and see what story emerges, what insights you can get. By this point, in terms of the way companies are using data, that debate has been resolved. There's no scientific method. There's no randomized controlled trials, whatever. There's exploring data. And man, if you can just find a correlation between two things, that's interesting. It's not some scientifically rigorous claim about causality. It's just something to go by. And so that Tukey approach in business has completely won out over the Fisher approach. Not so in the sciences. Fisher has absolutely dominated the way scientists use data. But over here in the commercial world, Tukey won.
But we digress a little bit. Let's go back to our timeline. There was a transformational change that happened sometime in the late 90s, early 2000s that we've talked about a few times already on the show.
The internet started breaking things.
As it does.
Yes.
But one of the ways that the internet was breaking analytics at the time was the sheer amount of data that it would create. It was now possible to track your customers or your shoppers as they went through your website. They basically left a digital breadcrumb trail that you could pick up and do all sorts of analysis on what did people put in their shopping carts, what shopping carts got abandoned, what did they look at but not put in their shopping carts. We were flooded with data about consumer behavior that we didn't have back at the grocery store.
Because more and more of life was moving into this electronically mediated form on the internet. Some of these businesses didn't even exist before. They were now on the web. And when smartphones really started to hit home in the years prior to 2010, the problem only got worse. By this point, data warehouses and the analytic tradition that we've got built up to this point were completely accepted, normal, mature technologies. Everybody had one or you wanted one. There are vendors competing for slices of the pie and all of that stuff, transforming your data and normalizing different versions of a customer record and storing it to make pretty reports with the results.
But the technologies at the time were designed for a much smaller amount of data and the ability to have a reporting window, meaning that you would look at a report from the previous day's sale the next day.
Yeah, the amount of data that the web and mobile devices were generating were completely overwhelming the old architectures. Those databases, even the analytical ones that were originally designed to save us from the problem of running analytics on the transactional system, they couldn't cut the mustard. Rachel, what's going to save us?
I have no idea.
Enter the era of big data.
Oh, big data.
There's a little disagreement on who first coined that term. Some say the American computer scientist John Maschie in the early 90s. Don't know what he was talking about then. I think most people say it was in 2005 by a guy who worked for the O'Reilly Media Group named Roger Mugalis.
And the definition was hardly precise. It kind of meant too much data for the tools that I was using.
Right. Yeah, we had this explosion of data. My old stuff doesn't work. That must be big data. But the era really opened up with a problem in analytics. How to make sense of the massive amounts of data that the internet and mobile devices were giving to companies. How to find the story in all that data.
So one of the companies that was perfectly poised to take advantage of all this internet data was Yahoo. Yahoo had search information, it had mail information, it had buying information. It was awash in data, but it didn't have the tools in order to do analytics. So one of its employees, Doug Cutting, created a revolutionary new tool, and they called it Hadoop.
That's kind of a silly name. Is this just now the internet era and things get silly names, or?
Well, no, actually, it was named after Doug's son's stuffed elephant.
I love that. And if you don't know this, the kind of mascot or the logo for Hadoop was an elephant.
Big yellow elephant.
Yeah, that is delightful. There should be more of that in our world. Now I want to bring a new voice into the conversation. This is Gwen Shapira. Gwen's the co-founder of a company called Noelle. She's a friend, former coworker, and an early developer in the big data space, particularly with Hadoop, talking about those early days.
So the way I would describe Hadoop is a massive parallel processing engine made easy and accessible to more developers than could ever before do massively parallel processing. And the context is that at that point in time, a lot of companies realized that they have a lot of data. They want to process a lot of data.
So Gwen mentions parallel processing, which means that Hadoop is actually a program that runs on a lot of small, cheap servers that act together like one big computer. We call systems like this distributed systems.
They actually feel that there is a business advantage in acquiring and processing more and more data. That was the whole thesis, and that was the big data revolution. And business people wondered what kind of deep insights are hiding in data that they haven't been thinking about before. Data mining is going way back before that, but it was the explosion of, I would say, software as a service, where your service is your application is on the internet, users are coming in, you suddenly have a lot more detailed data about your user behaviors than you ever had when you shipped a CD and asked them to install it, or even offered a download and asked them to install it. Suddenly you had extremely detailed behavior about user behavior.
Now, Gwen said software as a service. If you remember in our history of the cloud, we talked about application service providers. That was a term that got used around the year 2000. By 2010, the term was software as a service, or simply SaaS, spelled with two A's instead of two S's. Back to Gwen.
At that time, social networks became a thing. If you think about a lot of the big data technologies, Hadoop and so on, obviously LinkedIn, but also Facebook, Twitter, all those had massive amounts of data and ideas on how to monetize this data. So all this caused data to become a lot more valuable and something that a lot of businesses looked into. But traditional technologies made it either nearly impossible to process this data, or prohibitively expensive to process this data, depending on which database you used and which license it had. Both problems existed. Enter Hadoop, which promised to do this large-scale, efficient, massively parallel processing of any kind of data you throw at it. And it was open source, so potentially free. And even when you got it from Cloudera, it was massively cheaper than using traditional proprietary databases.
Gwen mentioned Cloudera. That was one of the companies that was selling Hadoop back then. This technology exploded on the scene. Everybody was talking about it, wanting to deploy it. Seemed like people were hoping their data was big enough to need big data in Hadoop.
It was one of these technologies that was designed to try to solve a problem, but it probably isn't where the industry is going to end up landing.
No, it's not. We're going to take a short break. After that, we're going to see where we do land and, Rachel, how some of this big data stuff actually affects our daily lives. But first, let's moonlight in the gig economy for a minute so we can afford a milk tea boba.
At the tone, please record your message.
This is Hannah from Denver, Colorado. Keyboard and Quill is made possible by StarTree, host of the Real-Time Analytics Summit, an annual conference that brings together professionals in the data space to discuss harnessing actionable insights from real-time data. Join us to learn, teach, connect, and have an amazing time with the best community in the user-facing real-time analytics world.
Register now at rtasummit.com. I'm Tim Berglund.
I'm Rachel Pedreschi.
This is Keyboard and Quill. We're going to keep going with how Rachel and I first met.
Woohoo! And how did that happen?
At this point, this blossoming of these so-called big data technologies, it kicked off a revolution in data infrastructure. There's a revolution that happened at the same time. New analytical systems were being built, some on top of Hadoop, some instead of Hadoop, new transactional databases, all following this pattern of being distributed systems. So lots of computers working together to act like one big giant database. And to answer your question, Rachel, we first worked together at one of those companies working with a high-speed, highly scalable transactional database called Apache Cassandra.
So we could say that this is like the historical beginnings of this podcast.
Yes, we can. Yes, we can. And just to apply this to daily life, if you're not familiar with it, if you use like Apple Messages or iCloud or Netflix or things like that, you use this underlying technology every day.
Out of Hadoop sprouted a few different sub-projects, but Hadoop itself didn't actually last for too long. By 2015, it was passé, being too difficult for non-developers to use and too old-fashioned for new designs.
Too difficult for developers, too.
Yeah, for sure. For making such a big but brief splash, I wonder if we could even consider it a success. We asked Gwen.
If you think about it, a lot of technologies that are absolutely fundamental today grew out of Hadoop, sometimes out of discovering gaps, sometimes out of discovering new use cases. But Spark was an answer for MapReduce, the original, solving the right problem, but being inefficient or possibly too simplistic. The use of S3, the fundamental storage layer of absolutely everything. And now I believe that very few companies actually run HDFS, and a lot of it is S3.
Now, that gets pretty technical in some places if you're not a person who works with these things all the time. We talked about S3 previously as like that big hard disk in the cloud, and Spark is one of the technologies that actually replaced Hadoop, one of its kind of children. Or
Heir apparent.
Heir apparent, yes. And it still powers a lot of analytics that happen today.
And to talk about some of the analytics that happen today, we would be remiss in our duties if we didn't discuss social media.
Absolutely. Rachel, how does Hadoop and Hadoop's children and grandchildren, how do they make Instagram possible?
So we hear a lot in the media about selling of data, right? And so what does that actually mean? And we're at an enviable point right now in this podcast to be able to shed some light on what does it mean for a social media company to collect data and to therefore sell it. So every time you use an app like Facebook or Instagram or TikTok, like we were talking about earlier, your digital breadcrumb trail is available to the author of that application. So then the applications like Instagram, like YouTube, can do analysis on who you are, what type of videos you're watching, and they can feed it through different type of algorithms to be able to say, hey, what's next on Tim's watch list? What else should I be showing to Rachel's children who are interested in trains?
Right. What are the right ads to serve to people based on their behavior inside the app?
And when you use these apps and you say, yes, I agree to not pay for the use of this application, you are agreeing to allow your data to be used by the applications to make better decisions on what ads they should serve you. And if you click on their ads, they make money. So it's in their best interest to say, hey, what clothing should we show Rachel because we know that she likes to do online shopping?
Exactly. So it may not be that Hadoop itself makes Instagram possible, but the tools that are a part of this big data generation, Hadoop's children and grandchildren and all these things, really do make the analysis of data at that scale possible.
But what's more important, and we'll cover in a later episode, is that these decisions have to be made in real time. So they need to be able to say, oh, look, Rachel's watching kitten videos. Maybe we should try to sell her cat food.
Yep. The technical details, the tools that have been in use for the past 15 years aren't important right now, but here's what is. There's a continuous thread of moving data from one place, we've called it the transactional database, the place where we kind of do our work on it, to another place, which is the place where we can ask it questions. We've called that the analytics database or the data warehouse, or in modern times, sometimes we call it the data lake. That's where we go to find the story in the data.
And remember the fight between John Tukey and Ronald Fisher? Fisher wanted all this mathematical scientific rigor, and Tukey wanted more to poke around data and to explore what he could learn.
Here's Dr. Swade again, tying these things together for us.
Why I say history is useful in this respect is because it allows you to look at the separate ingredients which had to converge, the point at which they converged, the point at which each matured, if you like, automatic electronic computers and all the rest of it, different trajectory of maturation, if you like, from information management, other things had to happen, and communication was the last two. But those are three. Now, right now, when we look at it, it's very difficult to disaggregate these things because we take them so for granted because the technologies are quite common. Digitization, integrated circuit, the high density chips that allow all this to happen. Of course, fiber optics, satellite technology, direct line of sight, microwaves, all that communication technology, all had evolved. All the substrate of the enabling technologies, integrated circuits, solid state electronics. And those matured, each of those threads matured at different times to converge. And if you like, analytics, many other things, analytics only became possible once all three of those were there. The harvesting of massive volumes of information, ability to communication, the ability to store the stuff. And then, of course, the presupposed, of course, are the algorithms and the computational elements to process it. So that, if you like, is where I would locate Babbage as the founder, conceptually, of the first thread I mentioned, which is automatic computation. The significance of automation cannot be understated. Nothing is possible until the thing itself has agency, and that mathematical rule is embodied in mechanism. Mechanism being a placeholder for things quite beyond mechanics.
This brings us to very recent days, but in all of the things that we've talked about, there is something that hasn't changed yet through this whole story of analytics. These systems are almost all what we call batch systems. That means you pile up data in a big, batch until you're ready to process it and then process it all at once.
I mean, this isn't allow 6 to 8 weeks for delivery, but there is something a little bit old-timey about it. Remember how we started this whole series about how life seems to be constantly getting faster? Well, our analytics are going to have to get faster too. And we'll get to that in our next episode.
Many thanks to Dr. Doron Swade from the Royal Holloway University of London, Bill Inman, the father of the data warehouse, Gwen Shapira, co-founder of Nile, Dr. Chris Wiggins from Columbia, and Dr. Matthew Jones from Princeton. You can find links to their work in the show notes. Also, thank you to Coastal Kites for the music you heard in our interlude. It's available on Spotify and Apple Music.
Our show is produced by Peter Furia, Noelle Gallagher, and Tim Berglund. It was written by Tim Berglund
and Rachel Pedreschi. It was edited by Noelle Gallagher, David Fine, and Peter Furia. And our amazing original music and sound design were created by Jeff Kite of The Voids.
Keyboard and Quill is made possible by StarTree, hosts of the Real-Time Analytics Summit. Register now at rtasummit.com.
You can subscribe to Keyboard and Quill for free wherever you listen to podcasts, including Apple, Spotify, and YouTube. Please leave us a comment and a rating if you have a minute. And if you're a data professional, you should check out the Real-Time Analytics podcast, which we launched in early 2023. New episodes every Monday, link in the show notes. I'm Tim Berglund.
And I'm Rachel Pedreschi.
See you next time.